All right, tell me, I'm sorry, give me 51. All right, so 51, I've got this graph. Did you just say you just kind of dabbled around? All right. Now, we talked yesterday a little bit about the order that you need to do things in. And if you think about the way order of operations goes, it's a little bit easier to see whenever you write it in this form because I do what's in parentheses first, then the multiplication, and then the shifts up and down. So I'm going to go left, right first. Okay, so I would start actually with my Did I tell y'all that yesterday? Shrink or stretch of X or Y. What did I say? Do? So you would do. All right, guys. Okay. If the shrink or the stretch happens here on X, yes, do that first. But I'm going to go inside these parentheses first when it's in this notation like this. Okay? All right, guys, y'all stay with me. All right, so I'm going to shift this left one. Does everybody agree with that? So it's really just going to I should have wrote some of the points down, but I didn't. And then the 3 there. Is that a vertical or a horizontal shrink or stretch? It's vertical because it's in front of the F, right? So whenever I times it by 3, that means take every Y value. Excuse me. It's not covered. And multiply by 3. So this point, it looks like this was 2, 2, which means this point now would be 1, 2, right? But whenever I shifted it, now I'm going to multiply it by 3. So it's going to be 1, 6. Right. So vertical stretch of 3. Now, if you did the stretch first, it wouldn't have impacted it because your shift is left to right there. So it would still been the same thing. By what point? So if it's a vertical, if it's on F that way, then you take X, your point XY, you keep X the same, but let's call this, if that's, I don't remember what I used on your sheet, but if it's A, you take that value of A and you multiply it to the Y value, whatever that value is. Do you have that little half sheet that I gave you? Well, it's after so the green was the original, right? And that point was 2, 2. I shifted it left 1, and that point became 1, 2. Then when I stretched it by 3 vertically, I multiplied this by 3, and that point became 1, 6. Right. Okay, so even if I had done a vertical stretch first, right, I would be at 2, 6, and then I shift it left. And the reason that's not really impacting it is because this is a vertical shrink or stretch, and this is a horizontal shift. So this isn't going to matter this way with the order in which you do that, if that makes sense. The only time it's going to matter is if you have something like this. And if that's the case, you would need to do this first. See the difference there? Does that make sense? Think about order of operations. And if you plugged an x value into here, if I wanted to know what is y when x is 0, then when you plug it in here, you would multiply before you add it anyway. All right, so I would follow this same procedure for all of these points. This is still going to be the same. I don't know what this point was. It looks like it was like -2, -4. But then I moved it over 1, so -3, -4 would become -3. I multiply that by 2, -8. So multiply it by 2, by 3. Am I just talking and y'all are just like, whatever? You understand what I'm saying? And then I still have to go, yes. So the process here, the process on this one would be move left 1 unit, right? Multiply all y's by 3, and then move up 2. Every point would need that done to it. Does that make sense? Does that make more sense? This is left. This is multiplied by 3. Only the y, and this is up 2. Yes, always. Does that make more sense? Yes, yes. Let your vertical shift be the last thing there. Do it last. Do it last. It was not, but okay. All right, so 22, even though you didn't have to do this one, without actually graphing it, we'll talk about what it does. What's the parent graph here? The cubic, that's right. What's the first one do? How is it different than the parent graph? This one is down to every point on that parent graph. And remember, we're using those points that we said were important points to graph with from your must-know functions. Every point on there goes down 2, which means you subtract 2 from the y value. Does that make sense? So 1, 1 would become what? 1, 1 would become, if you shifted it down 2, what would it become? 1, -1. And 0, 0 would become 0, -2. And -1, -1 would become -1, -3. That's exactly right. Does that make sense? And then on g of x, tell me what's happening. Left 4, down. How about the last one? Always go back to that purple one, that parent function. Yeah. Right 1 and then a what? What kind? Vertical stretch of 2, which means you take every point, and what do you do with it? Multiply what by 2? The y's. Only the y's. All right, if it's in front like that, it's vertical, and it's just done to y's. If it had looked like this, that would be horizontal. So it's done to x, but remember, everything x is opposite, right? So instead of multiplying by 2, I would divide by 2. The y's. Right. What else? 42? Transform the given function by a vertical stretch factor of 2 and then a horizontal factor of 1/3. All right, so let's do first vertical stretch of 2. So what does that mean? First of all, let's graph the parent and let's see what the, or not the parent, but let's look at f of x. This is a parent function, right? It's one of the functions you learned. What is it? The reciprocal function. Remember what reciprocal looks like? You had like 1, 1, -1, -1, right? How is this different than the parent function? What's happened to it? Left how many? 2. Why is it not up? This is up. This is left, right? So if I go left 2, that means I'm going to be 1, 2, right? Y'all with me? Adam, you with me? So this would be -1, 1. Left 2 here would put me at -3, -1, right? So it's the same graph. Ooh. Yes. 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 Everything moves over to every part of that graph. The asymptote was at 0, now it's at -2. Everything moves over. But that's not what I had to do. That is only getting to this. That's getting to what I started with. So now it asked me to take the green graph and do a vertical stretch factor of 2. What does that mean? Multiply every y by 2. That's exactly right. Every y by 2. So maybe you need one more point in here. Maybe you can do it without it. But this would not be -1, 1. It would be -1, 2, because I'm multiplied by 2. Right? Down here. So it's just going to make it into a more stretched out graph, which is what it's supposed to do. Yes? Girls, y'all with me? Everybody good? The equation says, what did it say, vertical? So I would just come here and multiply by 2 in front. Or you could say 2 over x plus 2. Same thing. Yes? Did it ask for the equation or the graph? I just assumed it was. Oh. Oh, I did too much work. Sorry, nobody even said anything to me. Y'all just let me go. Okay, and so then part B, I've got this same one. And it says a horizontal shrink of 1/3. What does that look like? What? Come in, Coach Kersey. Come in.
Hold your ears.
That's what they all say. Everybody hold your ears. Woo!
What's up, Miss Green? How's it going today? Good. You all right? Y'all doing all right over here? Yeah. Good. Henry, how about it, Bo? You all right? Get your water.
How are you today, Coach Kersey? It said a horizontal shrink by a factor of 1/3. So a horizontal shrink, remember everything x is opposite, right? So my question is, should it be 3x or should it be 1/3 x? So I want it to be a shrink of 1/3. If I gave you this equation, if I said 1/3x plus 2, would you tell me that's a horizontal shrink or a horizontal stretch? A horizontal shrink because it's opposite. So this is what you would need to use for the horizontal shrink. So that's a horizontal shrink of 1/3. It's always the opposite. Correct. That's correct. That's correct. Correct. All right, are y'all all okay now? Let me tell you what I'm gonna have you do. I'm gonna run you a practice packet. But before I do that, there's a couple in the book I want you to work on together while I get the other together for you. To get ready for your quiz tomorrow. What did we do? F of g of x has to equal x, and g of f of x has to equal x. And then, of course, what we did yesterday, the function transformations will be on there as well. Last year we talked about the transformations, but we really more looked at the equation and said what it was doing. This will be more graphing and coming up with the equations like you did on your homework. But I'll have you some more practice on that shortly. But I want you to get started on this one in class together